Hi everyone, how are you all? Myself Nagappa, you are watching Upper Chemistry classes. Now our today's topic is carbon family, that is also called 4th A group element or 14th group element. According to IUPAC system it is called 14th group. According to old system it is called 4th A group element. It is starting with carbon, so for that reason it is called carbon family. Now in the previous videos we had seen the alkali metals and also concept as well as numerical questions. In the same way, here also carbon family I am going to explain the concept and important formulas which need to be remembered for the mains exam as well as for the NEET exam. Okay na? So now you go through with the complete video till end, then you can get the complete information about carbon family. So for more videos, for more numerical questions, you can see in the description box also. Okay na? Let's get into the video of carbon family here. So in this case, some important concept we will see. Here carbon is the 7th most abundant element in the earth crust. We had seen in the last video, that is order of abundance of element. Now carbon is most versatile element in the world because in every species carbon is the major element. Now carbon isotopes are what? Carbon 12, carbon 13 and carbon 14 isotopes. This carbon 14 is the radioactive isotope of carbon whose lifespan is 5770 years only. So for that reason we won't discuss more about this carbon 14. By using this carbon 14 only we can calculate the ages of dead bodies, that is mummies, and also ages of rocks and ages of plants also can be measured by using this C14 radioactive isotope. Silicon is the second most abundant element. First most will be oxygen by mass in the earth crust. Second most is silicon. Now here, if you had seen the elements of 4th A group element, what are the 4th A group element here? Carbon, silicon, germanium, tin, lead. These are the 4th A group element. Among these 4th A group element, the carbon is the non-metal, carbon and silicon. The germanium is what? Metallite, and tin and lead will be what? Metals here. Now you can see here, whatever the carbon will be obtained in the form of graphite, allotropes, carbon dioxide, carbon monoxide. Silicon you will get it as what? In the form of silica. This tin will be appeared in the form of cassiterite. So SnO2 is called what? It is a ore of tin, it is cassiterite. Lead is obtained in the form of galena, it is a ore of lead metal. Ultra pure form of silicon and germanium are used in making transistors as well as semiconductors. Now we will see some trends which are followed in the periodic table. We will see. First, melting point you see. The carbon melting and boiling point mainly depends on the what? Metal to metal, that is element to element bond strength. It depends on the bond strength. Now if it is the stronger is the bond strength, then it will have the what? More melting and boiling point. Now you see in this case, so here carbon has the strong metal to metal bond strength. Due to that carbon in diamond or in diamond state, it will have the what? High melting point. So top to bottom melting point decreases till tin it will be. Actually tin should be what? Less than the lead, but a slight variation will be there melting point. Here boiling point is also same thing, but it is decreases gradually from top to bottom. But here the melting point will be tin is having the less than the lead. Okay na? Now next one is electronegativity. Carbon is the most electronegative element in 4th group. So remaining all elements will have the nearly same electronegativity, that is 1.8. Ionization energy, top to bottom ionization energy decreases. And if you had seen the catenation, which element is the most catenated element here? Carbon. Because of its CC bond is very high. Its bond strength is very high. It's around 380 kilojoules. So that is a high energy is there. For that reason, carbon will have the what? Highest catenation element. That catenation is also depends on the bond strength. It is also decreases from top to bottom. Okay na? So next one, oxidation state. These 4th A group elements are having general molecular electronic configuration is Ns2 Np2. So by loss of 4 electron it can shows the +4 oxidation state. If it is only Np electrons are lost involved in chemical bond formation, they will show the +2 oxidation state. If the Ns electrons are not participated in chemical bond formation, is called what? Inert pair effect. It is called inert pair effect. Okay now. So what is mean by inert pair effect here? The not participation of ns electron in chemical bond formation is called inert pair effect. Due to that inert pair effect only, the in a group, the lower elements in the group, whatever the bottom elements will try to participate in +2 oxidation state only. They won't form the what +4 because the ns electron will not participate in chemical bond formation. Now top to bottom +4 oxidation state decreases and +2 oxidation state will be increases from top to bottom. You can see here the lead +2 is the most stable, Pb +4 is the least stable one. Is that clear? It is due to inert pair effect. Now here you can see here carbon and silicon are rarely shows the what +2 oxidation state. Now you can see silicon hexafluoride is exist but SiCl6-2 is, if you had discussed the halide. So here silicon hexafluoride will be exist but silicon hexachloride does not exist. It is due to size factor here. The large sized chlorine atoms cannot be held by the small sized silicon atoms. So for that reason it is not possible. It is only exist. Now if you are comparing all these cases, here the what is the hybridization of central atom in silicon, germanium and tin in these complexes? sp3d2 hybridization of the central atom. Now this tin, whenever if you had seen these 4th A group element, top to bottom reactivity will be increases. So carbon, silicon and germanium, these will not react with normal water, but whereas tin, it can directly react with water and forms the water SnO2, cassiterite. Tin oxide will be formed and hydrogen gas will be released. But lead do not react with water due to formation of an oxide film on the surface. In total 4th A group element which is react with water, only tin. Now you can see here PbX2 is less stable than PbX4 and also PbO is more stable than the PbO2. That is PbO2 is least stable due to inert pair effect. It is act as what good oxidant. It will act as good oxidant it is. Okay, because it gains the electron and it forms the what PbO. And you can take here by loss of oxygen also it will form the PbO. So for that reason it is called oxidant or oxidizing agent. You can see there PbCl4 exists but PbBr4, PbI4 cannot exist because of the bromine and iodine cannot oxidize the Pb+2 to Pb+4. Inability. They are not having that ability to oxidize. Whenever silicon tetrachloride is on hydrolysis, we'll get the silicic acid. SiOH taken 4 is called what? Silicic acid. Now this carbon tetrachloride do not participate in hydrolysis because the carbon is not having vacant d orbital, so it will not accept the pair of electron, so it will not act as Lewis acid. If you had taken the oxides, here carbon dioxide, silicon oxide, germanium oxide are having the what acidic nature, but tin dioxide and lead dioxide will have the amphoteric nature. Carbon monoxide is neutral oxide, germanium oxide is acidic one, SnO and PbO will be amphoteric oxide. If you had discussed the carbon oxide, here carbon monoxide react with hemoglobin which is present in our bloodstream. It forms the carboxy hemoglobin. It is the more stable complex it will form. It is how much it will be stable than the oxyhemoglobin means around 300 times it will be more stable. So for that reason whenever it is carboxy hemoglobin is formed in our blood veins, so it can stop the water flow of oxygen into different parts. Whenever the oxygen movement is stopped, we'll get the paralysis and which causes the heart stroke and will leads to the death also if it is concentration of carbon monoxide is more. Now you can see the structure of carbon monoxide. In carbon monoxide, the dative bond is present between the oxygen atom to the carbon, and here in carbon monoxide, carbon participate in sp hybridization. It is a neutral oxide. In carbon dioxide is act as oxidant. Carbon monoxide will act as reducing agent. Now here in carbon dioxide, carbon participate in sp hybridization. It is an acidic one. Now you can see the structure also. It is carbon dioxide is also called anhydride of carbonic acid. Now we'll see the allotropes of carbon here. What are the different types of allotropes of carbon? We have two types of allotropes, amorphous and crystalline. So crystallines are important. I have not written the amorphous, just it is a coal, charcoal, lamp black, the coke, those all comes under what? Amorphous form of carbon allotrope. Crystalline form diamond, graphite, fullerene and nanotubes it will be. You can take here. Now you see first a diamond. Here carbon which is participate in sp3 hybridization in diamond. Each carbon bonded with 4 other carbon atom in tetrahedral manner. So participate sp3 and 109 degrees 28 minutes. So carbon to carbon bond length if you had seen in diamond it will be 1.54 angstroms. So or 154 picometers it will be 154 picometers or 1.54 angstroms. It has the 3-dimensional network like structure. The purity of diamond can be measured in the form of carat. 1 carat is equal to 200 milligrams of diamond. Okay na? So this diamond has the high refractive index. So for that reason it will have the water shining property. And it is a bad conductor due to absence of free electron because all the 4 valence electrons are involved in chemical bond formation. So the enthalpy of the standard enthalpy of diamond in carbon allotrope will be taken as 1.90 kilojoules it will be. Its density is taken as 3.5 gram per cc. Now if you had come to the graphite, in graphite each carbon bonded to 3 other carbon atom in trigonal planar. It forms the 2-dimensional sheet-like structure of hexagonal rings will be formed. It will be in 2 layers. The carbon to carbon bond length will be less than the 1.54, that is 1.42 angstroms or 142 picometers it will be. These sheets are held by weak van der Waals attractive forces and are separated by 3.35 angstroms or 335 picometer. It is a good conductor of heat and electricity due to presence of free mobile electron. And if you had seen the enthalpy of graphite, it is the actual natural abundance of carbon will be in the form of graphite. So for that reason standard enthalpy of that carbon is taken as in the form of graphite is taken as 0. But standard enthalpy of diamond it is not naturally available. So it's 1.90. You can take the fullerene. In fullerene also, so we have the water carbon participate sp2, nanotube also sp2. It made by heating the graphite in an electric arc in the presence of inert gases like helium and argon will get that fullerenes whenever graphite is heated. Now you can take here C60 fullerene consists of 12 pentagonal rings and 20 hexagonal rings are present. Now you can see here whatever the pentagonal rings are there, 5-membered rings can fuse with only 6-membered ring only. But whereas the hexagonal ring can fuse with any one of these rings. If you had discussed the rarely available fullerene, that is C70, it contains 12 pentagonal and 25 hexagonal rings. Okay na? So next we are going to see here. So graphite whenever it reacts with a strong oxidizing agent like KMnO4, it forms the hexacarboxylic acid. Benzene hexacarboxylic acid it will form. If you had seen the carbides, the carbon can form the water carbides with metal atoms. So like aluminium and beryllium, these two are on hydrolysis will get the methane. Aluminium and beryllium gives the hydrolysis of aluminium carbide and beryllium carbide produces the one carbon containing hydrocarbon that is methane. Calcium carbide and barium carbide which is on hydrolysis will leads in the formation of acetylene gas. Magnesium carbide leads in the formation of by hydrolysis propine, which is very important. Covalent carbides like what? Silicon carbide, boron carbides are comes under covalent. Silicon carbide is also called carborundum it is. Now you can take here interstitial carbides which are formed by transition element or inner transition elements. Now you can see here oxides of carbon. What are the oxides of carbon? It will be carbon monoxide and carbon dioxide it will be. First we will see the carbon monoxide. The carbon monoxide is formed by incomplete combustion of carbon or coke, or if it is fossil fuels or fuels which are incompletely burned, we will get the carbon monoxide. If it is react with metal oxide like this, we will get the carbon monoxide here. Carbon will act as what? Reducing agent which reduces metal oxide to metal and we will get the carbon monoxide by dehydration of formic acid. What it is? Formic acid on dehydration in presence of sulfuric acid will get the carbon monoxide. And also whenever this hot coke, whenever we are passing this steam, we are going to get the what? Carbon monoxide and hydrogen. The mixture of carbon monoxide and hydrogen is called water gas. So on hot coke, if you are passing the air, then we are going to get the producer gas. It is a mixture of carbon monoxide and nitrogen. Which is the best fuel here? Water gas is the best fuel. Now if we had seen the properties of carbon monoxide, here carbon monoxide is neutral and poisonous oxide which burns with blue flame. Carbon monoxide will act as reductant. Carbon monoxide forms the carboxyhemoglobin. It is 300 times. Just now we had discussed. So it will act as reducing agent, no, which reduces the iron oxide. It is used in the extraction of iron metal, and zinc oxide is reduced to zinc metal. Carbon monoxide is reduced to carbon monoxide whenever react with chlorine. It forms the most poisonous gas, phosgene gas. Carbon monoxide is used in the purification of metals in metallurgical process by Mond's process. By using Mond's process, you can purify the nickel. So whenever the impure nickel is heated with carbon monoxide, we will get the easily fusible nickel tetracarbonyl, which is on decomposition, we will get the pure nickel. Okay. Now we will see the carbon dioxide, second oxide of carbon. So carbon dioxide, how you are going to get here? Complete combustion of fuels or coal or charcoal, we will get the carbon dioxide. When metal carbonates are react with dilute acids, we will get the carbon dioxide. When in the cement factories, whenever the limestone is burned, heated, we will get the carbon dioxide. When limestone is react with the silica, we will get the carbon dioxide. These all will be preparation methods of carbon dioxide. You can see the properties. Carbon monoxide is what? It is an anhydride. Carbon dioxide is an anhydride of carbonic acid. This carbon dioxide has the acidic nature and oxidant. So forms the carbonic acid, which is an dibasic acid. CO2 is used as what? Fire extinguisher, because it is not support the flame as well as we can put off the flame also. So for that reason it is used as fire extinguisher. The dry ice, solid form of CO2 is called dry ice, which is used as refrigerant for the ice cream as well as for frozen food. Okay, now you can use the carbogen here. Carbogen is what? It is a mixture of oxygen and carbon dioxide. 5 to 10% carbon dioxide is used for the artificial respiration. This is very important. Okay, now so you can see here carbon monoxide can be estimated by this method. Whenever the carbon monoxide react with iodine pentoxide, we will get the iodine. The iodine can be estimated by titration with hypo, Na2S2O3 hypo. If you are doing the titration, we can estimate the iodine. Is that clear? Next, compounds of silicon you can see here. So what are the different types of compounds of silicon? It can form the feldspar, that is K2O, Al2O3, 6 SiO2. It is also written as KAlSi3O8, colonite, asbestos. These all will be compounds of silicon. So first one, silicon dioxide you take here. Around most of the 95% of earth crust is made up of silica and silicate. SiO2 is known as what? Silica here. The silica will have the two forms, crystalline and amorphous form. Crystalline forms are what? Quartz here. Quartz, and also you can take the tridymite and cristobalite. These are comes under crystalline form of silicon dioxide. But whereas amorphous form, azite, jasper and onyx, this all comes under amorphous form. Now this SiO does not exist at all. The silica will react with hydrofluoric acid and forms the hydrofluorosilicic acid. In this hydrofluorosilicic acid, the silicon will have the covalency 6. Out of 6 bond, 4 will be covalent bond, 2 will be dative bond. Here it will participate in sp3d2 hybridization. Now you see here the silicon will have the acidic nature. It can react with bases like metal oxide, metal hydroxide, metal carbonate, and forms the water silicate. Na2SiO3 is called what? Water glass. What it is? Water glass is formed here. Water glass. Okay, now. So now these all will be reactions of silicon dioxide. Whenever the silicon dioxide is heated with carbon at 2000 to 2500 degrees Celsius, we will get the silicon carbide. The silicon carbide is called carborundum. Okay, now it is having the diamond like structure. It has the high melting and boiling point. SiO2, if it is heated till 1600 degrees Celsius, it will gives the water quartz, used as piezoelectric material, which is used in the radio signals and TV signals. Okay, now piezoelectric material. And also quartz is used in the whatever the glass vessels which are made. Now structure of SiO2, if we had seen, in silica, each silicon atom is bonded with 4 other oxygen atom in tetrahedral manner. Now here covalency of silicon is 4. The oxygen covalency will be 2 here. It is what? Covalency. Now which is surrounded by the how many bonds? 4 bond. Oxygen surrounded by the 2 bonds. So its covalency is 2. Now it is sp3 hybridized. Now you can see here silicones. What are silicones here? These are synthetic organosilicon compounds containing which are having the SiO-Si linkages with R2SiO as repeating unit is called what? Silicones, which are having general formula will be R2SiON. It is having the what? It's a similar structure with ketone R2CO it will be. It is what? Ketone. So ketone and silicones are having the what? Similar empirical formula it will be. These are group of organosilicon polymers. You can see here how you are going to get these silicones here. Whenever alkyl halide react with silicon in presence of copper powder at 300 degrees Celsius, first we will get the alkyl silanes we will get. It is called alkyl silanes. Now the silanes on, these are called silanes. These silanes on hydrolysis we will get the what? Hydroxysilanes. Hydroxysilanes. The hydroxysilanes on polymerization will get the silicones. Okay na? So now different types of silanes will get. In silanes, that R may be methyl alkyl group or it may be aryl group, whatever it may be. If it is methyl group, it can form these 4 possible, but when this tetramethyl silane will be formed very less percentage. Now if you are taking alkyl trichlorosilane, if it is on hydrolysis, we will get the what? This product trihydroxysilane. This trihydroxysilane on polymerization will get the cross-linked silicones. So our cyclic silicones we are going to get, network silicones it is also called. Now if it is dichloro dialkyl silane on hydrolysis, we will get the dihydroxy dialkyl silane, which is on polymerization will get the straight chain silicones. The chain length of these silicones can be controlled by adding this CH3 taken thrice SiCl, which blocks the ends of these silicones. So for that reason it is used as what? To block the straight chain silicone ends, we are using this compound. Now what are the uses of silicones? Silicones are being surrounded by this alkyl group. These alkyl groups are what? Hydrophobic in nature. They repelled with water molecules. So for that reason they are used in waterproof substance, waterproof cloths or waterproof papers in the manufacturing. They have high thermal stability and high dielectric strength and also resistance to oxidation as well as for the chemicals also. So resistant towards the oxidation and chemicals. Used to prepare the grease and lubricants which can change in aeroplanes because these viscosity can be changes little with the temperature. So for that reason they are used as lubricant in aeroplanes. Used in surgical and cosmetic plants as they are biocompatible. These uses are very important. Next we are going to see the silicates. Which are called silicates here? Silicates are metal derivatives of silicic acid. Now whatever the silicic acid will be there, no, SiOH taken 4 silicic acid, which is on metal derivative will get the what here? Silicates will get. So what are the examples? Cement, glass. These two are the what? Man-made silicate. Most important man-made silicates are what? Cement and glass. The remaining will be slates, granite, bricks, feldspar, zeolite, mica, asbestos. These all will be comes under examples of silicates. Now you can see here these silicates contain SiO bonds which are repeatedly combined, which are very strong bonds. So for that reason which are used in the construction, in the cement also. The basic structural unit of silica will be SiO4 minus 4 it is. SiO4 minus 4 here. The 4 oxygen atom which are arranged around the silicon atom in tetrahedral manner. In this silicon will participate in sp3 hybridization. Now that is about what? Silicates. Now we are going to see the zeolites here. Zeolites are what? The zeolites are if aluminium ions are replaced few silicon ions in 3-dimensional network structure of silicon dioxide. Just now we had seen in the previous that silicon dioxide. Overall structure acquires the what? Negative charge. Whenever the aluminium ion the silicon ion which is present in the silicon dioxide is replaced by this aluminum, then what happens? One extra electron will be left over. So then it will get the what? Negative charge. It gets the negative charge. That negative charge can be balanced by the cations such as sodium, potassium, calcium ion can balance that negative charge. Then it forms the what? Zeolites. What are the examples of zeolites? Feldspar, zeolite. You can take here in seed silicate. So here 1/4 and 1/2 of silicon ions are replaced by, in sheet silicates, how much percentage? 1/4 or 1/2 of silicon ions are replaced by aluminum ions. Then zeolites are resulted. The type of zeolite will be ZSM5, which is used to convert the alcohol directly into gasoline. That is the important zeolite it is. Hydrated zeolites are used for the ion exchanger in softening of hard water also. Okay now. Now next we are going to see the most important numerical questions here. Now the CC bond length in diamond will be how much it is? 1.54 angstroms. The CC bond length, just now we had seen allotropic forms of carbon. Okay now, that is diamond. So in that carbon will participate sp3 and CC bond length is 1.54 angstroms it will be. Next, the number of pure atomic orbital at each carbon atom present in graphite. In graphite, what happens? Each carbon is surrounded by the 3 other carbon atom. Like this, it can form the what? Hexagonal rings in this manner. Okay na? So here, each carbon has the what? One empty orbital. One electron will be free here. Okay na? So that is one atomic orbital which is not participating in chemical bond. That is called what? Pure orbital. On each carbon, how many pure orbitals are there? Only one pure atomic orbital in graphite. Whereas in case of diamond, there are no pure atomic orbital. All the carbon containing all atomic orbitals are involved in chemical bond formation. Next, question number 3, you see, it is a compound. Tin exhibit the oxidation number. Okay na? In its compounds, tin exhibits the what? Oxidation number plus X plus Y. That is what? Tin can exhibit +2 as well as +4. X is equal to +2 and Y is equal to +4 it will be. Okay na? So that is 2 and 4. The product of X and Y they are asking. 2 into 4, that is how much? 8 it will be. Next one, the fuel gas having volume composition equal to X methane, Y % of hydrogen and 5% of nitrogen, 3% of carbon monoxide is called coal gas. The value of Y here, what is the Y value they are asking? In coal gas, what are the components which are present? Methane, hydrogen, carbon monoxide and nitrogen. Here the percentage of hydrogen will be how much? Around 48% of hydrogen will be there and 5% of nitrogen and 3% of carbon monoxide. 48 plus 8 it will be how much it is? 56. Remaining percentage will be how much it is? 46. That is around 44% of methane will be left over. Okay na? Is that clear? 44% of methane and 48% of hydrogen, 5% of nitrogen, 3% of carbon monoxide is called coal gas. The coal gas is the best fuel. Okay now, which has the high calorific value. How much it is? 21,000 kilojoules per meter cube. Kilojoules per meter cube calorific value when compared to the other gases, that is carbureted water gas. You can take the carbureted water gas, carbureted water gas and semi-water gas, water gas and semi-water gas. This is the order of their calorific value. Okay na? Which is the best fuel here? Based on the calorific value we can decide. Coal gas has the highest calorific value, so for that reason it is the best fuel, in which percentage of hydrogen will be 48, methane will be 44, remaining percentage will be nitrogen and carbon monoxide. Next one, the covalency of silicon and oxygen respectively in SiO2. In SiO2, what happens? Each silicon is surrounded by 4 other oxygen atoms in tetrahedral manner in the form of SiO-Si linkage. Is it or not? Now here what happens? So each silicon is bonded like this. Now here the covalency of silicon will be how much it is? 4. The covalency of oxygen, how many bonded atoms are there? 2. Now that is x and y, they are saying x is equal to 4, y is equal to 2. The product will be x into y, that is 4 into 2, that is equal to 8 it will be. Is that clear? Next, the number of electron that molecule of CO2 has. The number of electron that molecule of CO2 has. Now you see here, which molecule of electron will be involved in chemical, here the total number of electrons they are asking. So carbon has how many electrons? 6 electrons. Plus each oxygen will be 8. 2 into 8 electrons. That is 6 plus 16. That is how much it is? 22 electrons. Carbon dioxide will have the 22 electrons. Next one. OSiO bond angle in SiO4 minus 4 structural unit. It is a silicate ion. So in this case, the 4 oxide ions are surrounded by the silicon atom in the form of tetrahedral manner. So silicon participate in sp3 hybridization in tetrahedral arrangement. OSiO bond angle will be how much it is? Bond angle is 109 degrees 28 minutes it is. They are asking bond angle, no? Now next one, you can see here, the next one is the CC double bond length in C60 molecule is how many picometers they are asking. How many picometer it will be? It is 1.38 angstroms it will be, or else you can write it as 138 picometers it will be. Is that clear? Now next one, the percent p character of hybrid orbital of silicon in SiF6 minus 2. SiF6 minus 2, here the silicon atom is participate in which type of hybridization? sp3d2 hybridization. What they are asking here? The percentage of p character they are asking. What is the percentage of p character here? The total atomic orbitals are how many? 1s, 3p and 2d. Total will be 6. Total are 6. How many p are there? 3 into 100. So that will gives you what? 1 by 2 into 100, that is equal to how much? 50%. Now percentage of S will be what happens? 1 by 6 into 100. So percentage of D will be what happens? So that is 2 by 6 into 100 it will be. Is that clear? So they are asking percentage of P character, that is 50%. Next, number of 5-membered carbon rings in C60 Fullerene. In C60 Fullerene, how many 5-membered carbon rings are there? 12 pentagonal rings. That is called what? 5-membered rings. 12 pentagonal rings. And trigones in white phosphorus. White phosphorus P4, no? How many trigones are there? They are asking. Trigones are nothing but triangles in the white phosphorus. It is the actual structure of white phosphorus. You see, this is one triangle. This is another triangle, 2 triangle. This is 3 triangle, left one and right one. Okay, now total how many triangles are there in this? 4 trigones are there. 4 trigones are there. Okay, now so total it is called what? X is equal to 12 and y is equal to 4. They are asking x plus y, that is equal to 12 plus 4, that is 16 it will be. Is that clear? Next one. 2 layers of graphite are separated at a distance of how much it will be? 3.35 angstroms or 335 picometers. 335 picometers. Okay, now 2 graphite layers are separated. Number of oxygen atoms present around the silicon atom in solid silicon dioxide. In solid form of silicon dioxide, each silicon atom is surrounded by 4 other oxygen atom in tetrahedral manner. In tetrahedral manner. Each silicon is surrounded by 4 other oxygen atom in tetrahedral manner. How many oxygen atom? 4 it will be. Is that clear? That's about what? Complete about carbon family. Now this is about what? Carbon family from my upper chemistry classes. I hope so you liked it, and mostly all the points from the carbon family which I had covered. So thank you. Till now, those who not subscribe, please do subscribe. Thank you. Have a nice day.